Welcome back, everyone. Today, we are acting as the film directors of your next math paper. We're going to systematically build your blockbuster exam answer, scene by scene. Cut the filler, keep the action. In this strategy session, we are absolutely demystifying further percentages and interest, leveling up your math skills from basic decimals all the way to real-world financial mastery. If you are sitting the Cambridge mathematics exams, whether that's syllabus 0580, 0606, or any of the others, this is exactly where you need to be. We are taking a journey into the mind of the examiner. Because whether you're managing your own money in the real world or trying to secure those top marks on your paper, understanding the underlying mechanics of percentages is an absolute superpower. 665,500 euros. Now, I want you to imagine a ticking timer on your screen. You have exactly 3 minutes to solve this. How does a single 500,000 euro loan explode into this massive number in just 3 years? This is the ultimate challenge. Now, when faced with a past paper question like this, I usually see two types of students. First, there's Alex. Alex completely panics, overloads the page with raw mathematical facts and random formulas, but shows absolutely zero logical analysis. Then, there's Sam. Sam rushes the scene. Sam completely misses the specific command word requirements in the prompt, applies the wrong type of interest, and bleeds marks everywhere. Red ink all over the page. It's a disaster. But today, we are going to transform those flawed answers into perfect, green checkmarked masterpieces. To get there, here is our roadmap for today's session. First, we will master basic conversions. Second, calculating percentage shifts. Third, decoding simple interest. Fourth, unlocking the compound interest multiplier. And finally, comparing simple versus compound growth. Let's move to Section 1, Mastering Basic Conversions. This is Level 1, the foundation of your entire exam strategy. You literally cannot decode the command words of a math question if you don't understand the vocabulary. Understanding the place value of decimals directly connects simple fractions to their exact percentage equivalents. Think of it like translating a script. Look at the fraction 1/8. If you divide 1 by 8, you get 0.125. Because the word percentage literally means out of 100, you just multiply that decimal by 100 to get 12.5%. It's a seamless translation. 3/4 becomes 0.75, which is exactly 75%. 1/10 is 0.1, which is 10%. Recognizing these basic patterns instantly allows you to translate raw data without breaking a sweat, saving you precious minutes on that exam clock. Section 2. Section 2. Calculating percentage shifts. This is where we start building our actual answering framework. Let's imagine a scenario where a garage increases the price of a truck by 12%. The old school way, the way Alex would do it, is to find 12% of the price, write it down, and awkwardly add it back to the original price. It takes too long. Top students use what I call the PEEL framework for math. Point, evidence, execute, link. By treating an increase as a single multiplier, we streamline the entire execution process. Think about it. Point out that the original price is 100%. The evidence is the 12% increase, meaning our new target is 112%. We execute by translating that into a decimal, 1.12, and multiplying it by the original $14,500 price. Link it back to the context and boom, $16,240. One calculation, full marks. Before we continue, subscribe to our YouTube channel, Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Let's apply that exact same blockbuster strategy right now. We see this multiplier logic applied to a Saudi doctor's salary here.
If they earn 16,000 reals a month and receive an 8% raise, we don't need 3 different steps. We take the original 100%, add the 8% to get 108%, which gives us a flawless multiplier of 1.08. Multiply 16,000 by 1.08, instantly generating the new monthly total of 17,280 reals. One clean step. This multiplier concept is your golden ticket because it's the absolute key to unlocking the really big, complex financial calculations that examiners love to test you on later in the paper.
Section 3, Decoding Simple Interest. We are upgrading to Level 3, bringing time and money into the equation. When banking and investing enter the chat, you have to know the terminology. Examiners will try to trick you by swapping out words. The starting amount of money in any financial scenario, whether it's cash you put into a savings account or a loan you take out to buy a car, is called the principal. Sometimes you'll hear the command word capital instead. Don't let it throw you. For our framework, this is always the P in our formula. So the crucial point of evidence you need to extract is this simple interest formula, where I is the interest earned, P is your principal, R is the percentage rate, and N is the number of time periods, which is usually years. The reason it's divided by 100 is incredibly simple. It's just to turn that percentage rate back into a workable decimal, exactly like we did back in Level 1. Let's execute this. Imagine a ticking 60-second timer. If we invest a principal of $250 at an 8% rate for 6 years, this linear sequence maps out exactly how much standard interest we earn over time. You just extract the evidence and plug the numbers in. 250 times 8 times 6, which gives you 12,000. Divide that by a 100, and you link to your final answer, $120. That means over 6 years, your initial deposit earned exactly $120 in interest. It's predictable. It's a straight line. But listen to me carefully. The real world of finance and the hardest questions on your 0580 syllabus rarely operate on simple interest. Section 4, the compound interest multiplier. We have finally reached the boss level. Stop scrolling, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCS and turn on all notifications so you never miss our weekly exam strategy sessions. Let's get back into it. This right here is the math that builds fortunes, and it's the exact topic that separates the A-star students from the rest. What makes compound interest so beautifully complex is right here in the definition. Your money is compounding. It's growing by generating interest upon its own interest. It's like a snowball rolling down a hill, gathering more and more snow. You aren't just earning a flat, boring percentage on your initial deposit year after year. The interest gets added to your principal, creating a larger pile of money, which then magically generates an even larger amount of interest the very next year. Remember that massive number from the beginning of our session? Let's return to the Spanish builder who borrowed 500,000 euros at a 10% interest rate. We can visually track how rapidly that debt explodes over 3 years. In year 1, 10% interest adds 50 grand, bringing the total to 550,000. But in year 2, the 10% is calculated on the new total. 10% of 550,000 is 55,000. So now the debt is 605,000 euros. By year 3, the 10% interest adds over 60,000 euros, bringing the final debt to that staggering 665,500 euros. This is exactly where Sam usually messes up, trying to use the simple interest formula for a compound question. Now, calculating that year by year is a complete waste of your exam time. To master the time management matrix, we need the exponential shortcut. Thankfully, we have the multiplier technique from level 2. A 10% increase is a multiplier of 1.10. Instead of calculating year by year, we can just apply our 1.10 multiplier 3 times over. And as we know, multiplying a number by itself 3 times is just raising it to the power of 3. So 500,000 euros times 1.10 cubed gets us right to our answer in 3 seconds flat, 665,500 euros. It's elegant, it's fast, and it perfectly models exponential growth. This is the mathematics success blueprint in action. Now for a quick interactive workshop challenge. Scan this data table. You have 60 seconds to extract the core trend. Look at how aggressively this multiplier works on a high-interest loan. If you have a credit card interest rate of 27%, your multiplier is 1.27. By the second year, your debt is 1.61 times the original principal. And by the third year, 1.27 cubed is 2.05. Did you catch the trend? Your initial debt literally doubles by the third year, 2.05 times the original amount. This is why understanding this math is so crucial, not just for passing Cambridge, but for surviving in the real financial world. Section 5, Simple versus Compound Growth. Let's bring everything together into one final unified system. If an examiner asks you to evaluate the difference, the distinction between these two is incredibly stark. While simple interest offers a predictable, linear, straight-line growth sequence where interest is only ever applied to the original money, compound interest utilizes exponential sequences to drastically accelerate the numbers. With simple interest, time is just a passenger. But with compound interest, time is the ultimate amplifier because every single cycle applies that percentage to an ever-growing pile. Knowing the command words that signal which one to use is exactly how you jump from a B to an A star. And here is the final trap examiners love to set. Compound interest isn't always calculated annually. If interest is calculated quarterly, meaning 4 times a year, you have to adjust your multiplier. A 5% annual percentage rate divided by 4 quarters means your interest per period is actually 1.25%. Over 3 years, you don't just multiply it 3 times. No way. You have 12 time periods because there are 12 quarters in 3 years. So you'd multiply your principal of $600 by 1.0125 raised to the power of 12. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Now that you understand the mechanics of basic percentages, the sheer efficiency of multipliers, and the exponential power of compounding, how are you going to use these tools to conquer your exams in the real world? When you sit down for that paper, you aren't just looking at random numbers anymore. You're a director, commanding the scene. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here.